Today, we are diving deep into the internet's control plane. This is the invisible, logical system that figures out how to get your emails, your videos, well, everything from point A to point B across the entire globe in, like, the blink of an eye.
I mean, just stop and think about that for a second. There are literally billions of devices out there. Laptops, phones, servers, you name it. So when you hit send on an email, how on earth does it navigate through all that digital chaos to find one specific device, almost instantly? It seems kind of impossible, right? Well, it works, and it works because of a really, really elegant system of organization.
You know, the best way to wrap our heads around this whole thing is to think of the internet as one giant global postal service. Seriously, just like a letter needs a super precise address to land in your mailbox, every little piece of data needs a precise digital address to get where it's going. This analogy is going to be our guide through this whole thing.
And the absolute heart of this digital postal service is the IP address. Every single thing connected to the internet, from a massive web server to the phone that's probably in your hand right now, has its own unique IP address. It's the one piece of info that makes sure data gets delivered to the right digital doorstep.
So what is this digital address, really? Let's pull it apart a little bit. We're going to deconstruct it and see how it manages to be both a general location and a super specific identifier all at the same time.
Okay, so on a basic level, an IP address is just a unique string of numbers. It's what identifies a device on a network. It's kind of like the language that routers, the internet's mail carriers, actually understand. Without it, you've got no communication. Simple as that. But here's where it gets really clever. An IP address isn't just one long random number. It's got layers. Sticking with our postal analogy, think of it like your home address. Part of it is the zip code, right? That gets the letter to your general neighborhood. The other part is the street address, which pinpoints your exact house. In the digital world, we call these the network ID and the host ID. This two-part structure is what lets routers be so efficient. They just need to get the data to the right neighborhood first.
Now, this system works great, up to a point, but it starts to break down when you're talking about huge organizations. You can think of it as the corporate mailroom problem. A postal worker can easily get a letter to the front door of a giant skyscraper, but how does the mailroom sort through thousands of letters for thousands of different employees inside? Let's put it this way. Imagine a huge university with, say, 30,000 devices online. We're talking computers, printers, servers, the works. Does every single router in the world need to keep a record of all 30,000 of those individual addresses? I mean, that would be an absolute nightmare. The system would just grind to a halt.
So the answer is a big, fat no. The global internet doesn't need to know all that detail. All it needs to know is the university's main zip code, its network ID. Once the data arrives at the university's front door, an internal system takes over. And what that system does is divide the huge network into smaller, much more manageable departments. We call these subnets. Okay, so how do you actually create these digital departments? The solution is really elegant, actually. It's all about managing your digital real estate by borrowing a few bits to create a whole new layer of organization.
The whole process is brilliantly simple. You start with that standard two-part address we talked about, network and host. Then you basically borrow a few bits from the front of the host part, the part that's supposed to identify individual devices. You take those borrowed bits and you create a brand new third part right in the middle, the subnet ID. So now your address has three pieces: the main network, the internal subnet or department, and then the final host or desk.
But, and this is a really important but, this borrowing creates a trade-off. It's a zero-sum game. Every bit you use to create more subnets is one less bit you have available to assign to actual devices. So you have to make a choice. Do you need a lot of different departments, or do you need a lot of desks inside each one?
And this table here shows you that trade-off perfectly. Look at this. If you borrow just 2 bits, you can create 4 subnets, and each one can have 62 devices. Not bad. But if you borrow 4 bits, you get 16 different subnets, way more departments, but now each one can only handle 14 devices. It's a critical decision that a network administrator has to make based on what they actually need.
So, why go through all this trouble? Why bother with borrowing bits and creating subnets? Well, because this whole hierarchical system is what makes the internet so incredibly fast and scalable. It makes the job of our digital mail carriers, the routers, so much easier. And here's the secret. All of this subnetting stuff, it's an internal secret. Routers out on the big global internet, they have no idea it's even happening. They don't know and they don't care. Their only job is to get the data packet to the main network address, to the front door of the building. That's it. This keeps the global routing tables lean and mean.
So let's follow a packet on its journey. An external router sees a packet addressed to this number here. It doesn't analyze the whole thing, it just looks at the first part, the network ID 137207, and goes, okay, I know where that neighborhood is, and sends it off to that organization's main router. Then, once it arrives, the internal router takes a look. It reads the next part of the address, the subnet ID, and says, this one goes to the engineering department, and it forwards it to the right internal network for that final delivery.
So let's zoom out for a second. What we've really been talking about is the Internet's invisible map, the logical structure that stops the whole thing from just collapsing into total chaos. And that is why this all matters.
So if you're going to remember anything from this, let it be these three things. 1. IP addresses are just the Internet's postal system, complete with a zip code and a street address. 2. Subnetting is that clever trick for creating internal departments to keep huge networks organized. And 3. This whole two-level system is what makes the Internet so fast and allows it to grow without falling apart.
At the end of the day, the Internet works because of this beautiful balance. You've got global rules that get data to the right general area, and then you have local control that gets it to the exact right device. This hidden architecture, it's the bedrock of our entire digital world.
And that really leaves us with one last big thought. We've built this incredible system, but we're on the verge of connecting trillions of new devices, everything from smart toasters to self-driving cars. So the question is, how will this digital address book, this control plane we've just talked about, have to change and evolve to handle that future? It's something to think about. Thanks for watching.